All right, let's solve some exponential equations here, but without the use of logs. Oh my goodness. Oh my goodness. All right, let's see what we can do with it, right? We might have to use our little brain skis right here a little bit. Okay, so I got 3 to a power and I've got 9 to a power. I can't set those exponents equal to each other because we have different bases. So I don't know if the exponents are the same, but hey, if I can get the same bases, then I can set my exponents equal to each other. Let's take a look. So could I get 9 to be 3 to a power? Heck yeah, it'd be 3 squared. My exponent is still 4x plus 3, and I'd still have this side being the same. I'm almost there. Now next, my exponent properties tell me I should multiply this and that together to become 1, right? So if I do that, my left side still stays the same, and I'm going to have 3 to the 8x plus 6. That 2 does get distributed to both parts, right? Because I am multiplying them. Now I have 3 to a power and 3 to a power. It would make sense that those exponents would need to be equal to each other, right? If the bases are the same, the exponents should be the same. Okay. So what I can do is use the one-to-one property of exponents to set those two exponents equal to each other. So I'd have 2x minus 6 equals 8x plus 6, and now I can solve this nice linear equation. Easy peasy, lemon squeezy, algebra 1 awesomeness. I'm going to subtract 2x, and I'll get 6x. Now, don't make a common mistake and accidentally cancel out these 6's because we're really subtracting 6, which gives me negative 12 over here. When I divide by 6, I'm going to get x equals negative 2. Now, what's nice about exponentials is we don't really have this potential for extraneous solutions because exponents can be positive, they can be negative, they can be 0. There are no domain restrictions when it comes to exponential functions, so we don't have to worry about that extraneous solution in that regard of it not working in the original. We got to make sure we don't make any mistakes. You can always test it in there. I'm confident it's negative 2. All right, let's move on. Solve for x. This one looks weird. We got fractions, man. I don't like fractions. What can we do with that? How about this? I see a 4 and I see an 8. Perhaps I can write these both as a base of 2. The only thing with the first one there on the left side is it's a fraction. So it's going to need to be a negative exponent. So I could rewrite this as 2 to the negative second, and then I have 3x minus 1. 2 to the negative second is like 2 to the second, which is 4, but the reciprocal of it, which is 1/4. Negative exponents give us reciprocals. Remember that. All right, next up, we got 2 to the third. That one's not too bad, and I'm going to have x plus 11 thirds. Man, we had fractions and fractions, but perhaps that'll work out. Boom, boom. And I'm going to multiply there. So I'm going to have 2 to the negative 6x plus 2 equals, and then I'll have 2 to the 3x, and then I have plus 11 because those 3's ends up canceling each other out. No more fractions. This is wonderful. This is fantastic. All right, can we set our exponents equal to each other? Yes, because we have like bases. So I'm going to have negative 6x plus 2 equals 3x plus 11. Let's see here. Subtract 3x, I get negative 9x. Subtract 2, I get positive 9. So x equals negative 1. Bingo, bango. We done. I think we got time for one more in this video. One more. All right. I've got 8 to a power and 2 to a power. Okay, so I'm thinking 2 will be our base, right? So 2 to the third to the 4x minus 5 equals, this one doesn't need to change, but I'm a little terrified because I see an x squared, a quadratic. Oh boy, what are we going to have? All right, so I'm going to have 2 raised to the 12x minus 15 equals 2 raised to the x squared plus 17. I've got like bases, so I can use my one-to-one property of exponentials, right? One-to-one property of exponents and set those equal to each other. So 12x minus 15 equals x squared plus 17. That's better. Oh boy, I got myself a quadratic here. So I need to set everything equal to 0, right? That's my strategy when solving quadratics. Bring everything to one side. Let's do it. So I'm going to subtract 12x. I'm going to subtract or add 15, and I'm going to get 0 equals x squared minus 12x. And then if I add 15, I'm going to get plus 32. What do I do here? Factor. All right. What multiplies to 32 and adds to negative 12? Well, that would be negative 8 and negative 4. Those two multiply to positive 32. When I add them up, you get negative 12. We are good to go here. So I'm going to set each factor equal to 0. And I'm going to get x equals 8 and x equals 4. Both of them will be my solutions here. Both those numbers would work to satisfy the original equation, which is right up there in light blue. Woo! That was a beast. But you guys handled it because you're rock stars. All right. You guys have a wonderful day. America, freedom, rock and roll, Costco, Riverdog, Jenny on the gram, Yo-Ro, and I don't know what else.